Greetings. Today in this video, we will try to understand the physics of plasma, learn how it is created in laboratories, and where it is used. So, plasma is a state of matter where gas atoms become ionized. Plasma is called the fourth state of matter because it is distinct from solid, liquid, and gas. Just as heating a solid turns it into a liquid, and further heating turns the liquid into a gas, similarly, heating a gas turns it into plasma. In plasma, both free electrons and ions are present, with their numbers roughly equal. Additionally, due to the presence of free electrons, plasma is electrically conducting, meaning current can pass through it. Now, let's try to understand how plasma is created. As you all know, everything is made up of atoms, and these atoms consist of electrons, protons, and neutrons. Electrons orbit around the nucleus, which is formed by the combination of protons and neutrons. In any atom, the number of electrons is equal to the number of protons, resulting in no overall charge on the atom. However, if an electron is removed from the atom becomes positively charged due to an excess of protons. This state is called an ion, and the process of removing electrons to form ions is called ionization. To ionize atoms, we need to supply external energy, known as ionization energy. But where does this energy come from? The easiest way to supply energy to gas is by increasing its temperature. Heating increases the kinetic energy of gas atoms, causing them to collide with each other, which in turn knocks electrons out of the atoms. However, to increase the kinetic energy of gas atoms to the required extent, temperatures of approximately 3000 K to 10,000 K are needed, which is quite challenging to achieve in a laboratory setting. Therefore, an alternative method is used to create plasma. In this alternative method, an electric field is applied to the gas. Since electrons and ions are charged particles, applying an electric field exerts a force on them in opposite directions. This force is sufficient to ionize gas atoms. The electric field accelerates electrons and ions, causing them to collide with other atoms and turn them into ions. This accelerates the process of ionization, leading to the formation of plasma. In this way, plasma can be created in a small chamber inside a laboratory. As you may have seen in photos of plasma, it exhibits a unique color like pink or blue. Now let's try to understand where this color comes from. As we mentioned earlier, when we give energy to an electron, it moves away from the atom. When this electron returns to its orbit, it releases some energy. This process is called recombination. In plasma, both ionization and recombination processes occur simultaneously. During recombination, if the energy released falls within the visible spectrum, we see a specific color. Thus, by observing the color of plasma, we can determine which gas atoms are present. For example, the plasma of hydrogen gas appears pink, while the plasma of argon gas appears red. According to scientists, approximately 99.9% of our universe is made up of plasma. Our Sun, as well as other stars, are made of plasma. Plasma is also present in interstellar and interplanetary space. Phenomena like lightning or auroras, known as northern lights, are also caused by plasma. Now let's try to understand where we currently use plasma and what its potential uses could be in the future. One of the primary applications of plasma is in fluorescent bulbs like tube lights or CFL bulbs. These bulbs contain mercury gas, which is ionized to create plasma. You may have also seen neon lights, where neon gas is ionized to produce plasma. To change the color of neon lights, other gases are mixed in. Besides, plasma finds applications in the semiconductor industry and various medical applications. In the future, plasma technology could be used to generate energy through fusion reactions. In fusion reactions, two nuclei combine to form a heavier nucleus, releasing a significant amount of energy. With the help of plasma, controlling this fusion reaction becomes feasible, and the released energy can be converted into electrical energy. I hope you have learned a lot about plasma from today's video. Through this video series, we aim to explain the complex questions of physics to people in a simple manner, thus fostering curiosity for physics among the audience. If you like this video, please like and subscribe. Jai Hind, Jai Bharat.